Okay, so here we're asked to find the power series representation of the following function. So first of all, let's think if we can reduce this to be the sum of a power of a geometric series. Yes. First of all, we should not be afraid of that x cubed. That's just a power, so we can always multiply it inside a series. So I can see my function in the following form. There's this power times this function that sort of resembles the sum of a geometric series. So let's work to express this as a power series. So our goal is to use the following formula. So we want to see a 1 here, and we have a 2. In order to get rid of the 2, I'm just going to factor it out from the denominator. So I get 1/2. Here I'm left with 1. If I take out a 2 from x squared, I will have x squared over 2. Okay? You can always check that if you multiply this out, you get back to this one. And in fact, you do. Now, this is exactly in this form for r equals x squared over 2. So I can use in this formula replacing r by x squared over 2. Okay, now let's just write it in a better form. A fraction to the power n is the same as the numerator to power n and the denominator to power n. So x squared to the n is x to the 2n. Remember, you multiply exponents when you have a power of a power. And then here I simply have 2 to the n. Then I should bring this 1/2 inside. And it's going to increase this power by 1. Okay, so that's my series representation for this function. Now remember, our original function is x cubed times this. So I can replace this by the power series that I found. And then finally bring, this was x cubed. Bring this power inside. And I can combine it with this. The multiplication results in addition of exponents. And this is my final answer. That's a power series representation for my function.